we're live. Hello, everyone. Welcome here.
Good morning,
everybody.
It's a full panel today, Elizabeth.
It is a full panel, yes. Very exciting.
Yeah. Is this one of our bigger panels in the last year or so?
Yeah, it's definitely up there. It's always nice when we have various guest speakers on.
Yeah,
we'll try not to all talk at the same time. How you doing? Sorry.
Elizabeth has been doing a good job in recruiting a variety of very interesting guest speakers, and today is no exception. So very excited about that.
Absolutely. Yeah, let us know in the chat panel there as well where you're tuning in from. We see some people are starting to chime in.
Well, Elizabeth, I know we've got a busy agenda today. Should we get started with our program?
Yes, let's do it. All right, so welcome everyone to Cloud Revolution, exploring the new wave of serverless spatial data. And I'll pass things over to Dale for our next slide here.
Yes, I'll just say that this is a very exciting webinar for me personally and the crew here, because we've been following this trend of cloud native data formats for several years, actually. And part of the effort at SAFE has always been to go not only where the data is now, but where it's going to be. So we can make sure that we're there to support our customers, often in the migration of data from where it is to where it's going to end up being as well. And as well being a good consumer of these data destinations, whether it's data systems like Snowflake, or actually one of the first things we ever supported before anybody else was the Esri SDE, and now these modern cloud hosted data formats. And so the line that we wanted to open with, harkening back to our old days, was zip, clip, and ship. And I wonder how many in the audience remember that tagline from, say, from about 2002 or 1 all the way to maybe 2008. Yes, there's some that do clip, zip, and ship with our old Spatial Direct product, which turned into FME Server and got extended and made far more wonderful, to the modern tagline, which I just learned yesterday from our guests, and let's have that, to read what you need. And so that's the thing I'd like you to kind of internalize, is that this is all about reading what you need and facilitating that in this world of overwhelming data volumes. And so this is, I hope, a new set of tools that we're going to introduce you to that prepare you for being able to maximize the abilities that are out there. And you're going to hear some really great stuff from our two speakers. Chris is going to kind of provide the why this matters. And then Michelle is going to tell you what this is all about. And then Kaylin and Dean are going to tell you the how. And we do recognize we may run a little over time. We will stop on the hour at 9, but if you can, hang around for the overtime, or Elizabeth promises me she'll make a recording available afterwards, should we leak over into the next bit. But that's my kind of intro, and I'm so excited for this whole webinar and that you're all joining us today. And let's keep rolling, Elizabeth.
Fantastic. All right, so we have a great panel of speakers today, and I'll pass it off to each of them to introduce themselves briefly. Dean.
Yeah, I'm Dean Hintz. I've been with SAFE a little while, and one of my jobs is I'm the strategic solutions team lead, as well as the product manager for open standards. So you'll hear me talk a bit about open standards today, because that's one of the great things about cloud native, is all these standards we're talking about are in fact open, and it just makes it a lot easier to share and collaborate with them. So that's me.
Hey, I'm Kaylin. I'm also on the technical support team. Been with SAFE just over 3 years now, and you can typically find me on the FME community or poking around in cases.
All right, and I'm Dale Lutz. I'm one of the two co-founders of SAFE, and thrilled to be able to join today as well. And Elizabeth, I have a bad feeling about one of our guest speakers.
Yes, we may have lost him off the stage, so he'll be back soon. I think he's just having some tech issues, but for now, I'm sure we can give him a brief intro and we'll hear from him soon.
Yes, so I'll go ahead, Michelle.
Yeah, hi everyone. My name is Michelle Roby, and I'm a developer advocate at Radiant Earth. So I get to work in a really cool space between a lot of techie side and then a lot of education side. So I'm really happy to be here today with all of you.
And Chris is a VP of Product Strategy and Partnerships at Planet, and has been very, very involved incubation and birthing of these new data formats to solve specific issues for the entire industry. And I'm sure hoping he's able to join us to present his slides, but if not, we will piece them in afterwards into the recording and make sure you all get them, but we'll see if he's able to join.
Yeah, absolutely. All right, now we'll head on over to our agenda here.
Yes, so we're just working our way through just to give you a sense. We're gonna, really the key piece of this is the perspectives from Michelle over at Radiant Earth and Chris at Planet. And then we'll dig into a few of these formats that we have added to FME and kind of show you how you actually can make use of them and what their possibilities are. So there you can see sort of the alphabet soup of all of them. And GeoParquet, we also have some things. Dean's got a few lessons learned that he'll present at the end. And then we'll have some Q&A. And actually, we may stop for some Q&A along the way as well, depending on how it goes and Elizabeth makes the call.
Yes, absolutely. All right. If this is your first time in Livestorm, just a couple tips here before we get started. If you have any audio or video issues, click that help button for 4 simple steps there. Any questions you might have, do get those into the questions tab on the bottom right. We will have Q&A at the end. And then also after Chris and Michelle's section, we'll have Q&A. So if you do have any questions that come up during each of their sections, please do get those in as they pop up for you. And keep letting us know where you're tuning in from in the chat. All right, with that, we'll pass things over to Chris. Hopefully you're all good to go with your internet now, Chris.
Yeah.
Fantastic.
Can you hear me?
Yeah, perfect. And while Chris is sharing his screen here, I'll get our presenters to turn off our webcams to save on some bandwidth here.
Yeah, like Dale, I'm just curious, sort of what was your first experience with Cloud Native while we're waiting?
Right, I just remember reading about, well, it was actually, I remember being at a conference with Chris and Peter Becker, and they were talking about Cloud-Optimized GeoTIFF. And that would have been at a Planet conference a long, long time ago. So Chris, I'm just filling the air while you get, but I remember standing there and listening to what Chris and Peter Becker were talking about and realizing that this was a fundamental mind shift change in the way one can imagine dealing with data. And it's been just a really exciting thing to watch these all evolve since then. And with that, I'm handing it back to Chris, who looks like he's 100% set up.
Pretty much there. Thanks, Dale. So yeah, Chris Holmes. Sorry, I missed the little intro. I'm at Planet with most of my time, but then kind of spend time with other organizations working on standards and various things. Dale asked me to talk about this. I've done a number of overviews of Cloud-Native Geospatial, but Dale's particularly interested in history, so it was a fun opportunity to kind of tell this from a historical perspective. I think it'll hit on a lot of the sort of reasons and the why, and then the other presenters are going to do a great job getting into the what and the particulars. So telling this history is a great chance to go back through my email from pretty early days at Planet. And so Jed, who was set to speak in the webinar, but fortunately couldn't be here, he had just taken over the open data program at Amazon. It was pretty small at the time, and it was really just these smaller data sets that people were, for the most part, downloading, which didn't really get at what Amazon was hoping to achieve. There weren't data sets that were interested in me, but I wrote Jed to see if they might be interested in hosting Landsat. This was a bit selfish. Planet was paying for maybe 15 terabytes of Landsat just for our internal purposes, for calibration. And it was kind of great if it was free for us. But I'm a very open guy at heart. So having Landsat on S3 would help a lot of people. And since it was pretty painful to get the data from USGS at the time. So Jed wrote back that hundreds of petabytes would need this proposal. And I'm pretty sure I took that to mean, yeah, this isn't going to happen. You know, it's this big org. Amazon certainly has a reputation of being very tight on costs, but he came through. They committed to hosting all of the Landsat 8 archive and keep adding all the new images that come in. And then we found out that both Esri and Mapbox were also hosting lots of Landsat data on AWS for their own purposes. So they were keen to use public data for free. So everyone started collaborating to make the data available and figuring out how to format it. And the core idea was to not just host the data, but to make it much more accessible, especially for users of the cloud. So one of the key things that made the data accessible was including overviews. This pyramid of lower resolution copies of the data. These add overhead, but they let many applications sort of display the data without having to download hundreds of megabytes. The overviews, along with tiling, sort of combine with this really cool little technology that had been sitting in GDAL since 2010. It's called VSI curl. Pretty obscure. This was this blog post that Chris Schmidt wrote when they kind of figured it out, but it lets GDAL, or really any technology built on GDAL, like Safe FME, stream just what they need from remote files. So it uses this key property of HTTP protocol called range requests, and lets us kind of treat geospatial data like an MP3. You know, you're gonna move forward back, you just skip around to just the parts you want instead of having to wait for this whole thing to download. And once the data was available on S3 and organized in a way for streaming, it enabled this kind of little explosion of innovation. This was a cool app called Remote Pixel, and it let anyone easily view any landside image, as well as Sentinel and CBERS that started to organize in the same way. And you could even change the bands on the fly, super easy to use. But there were many applications and tools that started tapping into this new way of accessing data. So then we thought, why not reuse this pattern for any data, not just Landsat? Evan Roll of GDAL wrote up these kind of rules. We weren't trying to make this super formal spec. It now is actually a complete OGC specification, but it was just a wiki page in the GDAL docs, and it included instructions how to easily make one. You can just use existing GDAL commands. Later, there's a GDAL driver and yeah, clearly lots of other tools, but at the time you could just put a special incantation in. You'd have a Cloud-Optimized GeoTIFF, and you could also sort of easily read it with any tool. So I think I coined the name. It was the start of this pattern of my very non-creative names for standards. And I put up the website. I had never put up an HTML page and just sort of hacked it. And it was really to kind of make it a thing. Planet started making all of its data available as COGs. Maxar also translated some of the imagery too. And I think that's one thing we've done well with Cloud Native formats is really thought about that ecosystem early and getting major amounts of data and more tools available in them. And one of those things that we did that I think was key was make it very easy to validate. So there were command line tools and these online validators, so anyone could tell if something was actually a COG and would kind of perform well. The adoption was quite rapid, actually. And I think the biggest reason for this was we weren't trying to push this brand new format on people. Everything was still a GeoTIFF, so completely backwards compatible with every existing tool. You could just reorganize the file a little bit, put it on the cloud, and suddenly many more tools be able to stream it on the cloud. So to show a super quick example, probably most people have heard of COGs, but I kind of like to show the basic how it works. This is a 3.7 gigabyte file. So on a fast connection, it's maybe 10 minutes to download, many hours on a slow connection. But if you want to even just like check this out, see what it is, you've got to wait, to view it the first time. But if it's a COG, you can view it right away. This shows a site that lets you load any URL with a COG into web tiles that you can share with others, share that link with them. So I take a public URL from that file on Google Cloud, add it here, and I can instantly see it and zoom into full detail, full resolution. This isn't just a preview, this is the full data set. But it enables more than even just simple visualization. Tools like Foursquare Studio show what you can do fully in the browser. So this same COG is a full bit depth image with multiple bands. So you can do NDVI, false color visualizations, put it on 3D overlays. And they can also be used in desktop GS. This isn't sort of just a web thing. It's really like a cloud streaming thing. So Q just demonstrates how the data can be streamed. You're not having to wait 10 minutes to download to just see, hey, maybe I don't want to use this file. You can use it with any raster analysis tools on the COG that QGIS has, and then ArcGIS Pro also has great COG support now. So all of its advanced tool, raster toolbox, is accessible, usable, same sets of operations. And then the whole suite of ArcGIS tools now actually has quite solid COG support. So their services and clients and sort of everything, they've really embraced it as well. And then you can use this exact same COG in Google Earth Engine using their scale out analysis framework. You don't have to import all your data into Earth Engine. It too will just stream and analyze the COG directly. And then there's numerous other tools, including, of course, SafeFME, which you'll hear more about in the webinar, how to actually make use of it. So there's now vast amounts of data available as COGs. This is Planetary Computer from Microsoft, and it's got a lot of global data sets all available as COGs. There's probably 50 petabytes of COGs, and that's just a portion of the entire ecosystem. A whole bunch of commercial data providers and governments have been embracing COG. And what you see is not just this, little web visualization. Any of the data here can be streamed into any tool in the COG ecosystem. So Planetary Computer is built for the ground up with COGs and also with STAC, which is a great segue into the next topic. And yeah, this GIF continues to go on showing higher and higher resolution imagery that you kind of select. So the next standard I work on is called SpatioTemporal Asset Catalog, sort of continuing my trend of these non-creative names. I started my career implementing OGC specifications in GeoServer, but when Planet Data created its data API to make it easier to search imagery, I couldn't really make this good argument to use OGC's WFS or CSW. They didn't really fit the kind of billions of items we needed to handle, and they're built on XML in a very sort of JSON world at the time. But it felt like there was a real place for interoperability when searching for satellite imagery. So if as a user you wanted to get imagery, you would have to either kind of pick one provider or go to lots of different sites to be sure you were searching for all the imagery in that area. And the situation was even worse for APIs. Everyone had JSON, but kind of slightly different APIs, different ways of representing the data. So in 2017, we gathered 14 organizations to try to tackle this problem. Going into it, I thought we'd come up with this API that would make it easier to search COGs, something like OGC CSW, but RESTful and scalable. And we made good progress on the API, but one group hacking away made this thing we called a static catalog. And I thought this would be this nice little side thing. The API would be the real spec, and we'd have these big servers that would crawl these little files, for Landsat on AWS. But it turned out you didn't need a database. You didn't need a server. You just needed data on the cloud. So the static catalog team, what they came up with sort of became the center of the specification and indeed the entire ecosystem. The core building block's just this JSON file. It doesn't require you to put it in an API, but you can. You can layer on an API to filter data, but you can just publish your data, make it available for others to browse and search. And I also originally thought we need this kind of HTML version of the JSON file, but we ended up with was a lot more elegant. This stack browser tool that you see can transform any set of JSON into a fully interactive web experience. And if it's got a Cloud-Optimized GeoTIFF, you can zoom in at full resolution and tap into other cloud-native formats. You can even drop into full screen mode, see it full resolution, but powering all of this is just a JSON file and a COG. So since COG and STAC, there's been a number of great cloud-native geospatial standards, but I'm going to let Michelle explain those as I was less personally involved. But I want to touch on the latest standard I've helped lead. And I've sort of pledged this to be my last format I work on, but my hunch is this is going to be the biggest one. A good part of that is I think vector data is where geospatial most likely can really go mainstream to general IT. And so I started my career in vector data. First thing I coded was a MySQL driver for GeoServer, but then I didn't really understand raster data until I came to Planet. And I hadn't thought much about vector data in the past 8, 9, 10 years. But I got this fellowship with OGC and got sort of time to explore. The GeoParquet repository actually started as just this kind of attempt to survey the state of cloud data warehouses like BigQuery and Snowflake. And there are these awesome tools that do geospatial, but the kind of import-export story isn't great. They would do GeoJSON or well-known binary kind of differently. And we thought we were just going to work to make those compatible. But I got intrigued because they all supported this format called Parquet that I had never heard of. It was invented in 2012 by the Hadoop community, basically as kind of a better CSV file design for the cloud. And it's just more compact, faster, and it's seen huge adoption by these mainstream data engineering and data science teams. And it turned out the GeoPandas project was already supporting writing geospatial data to and from Parquet. And there's even the start of a standard because our users were trying to do the same thing. So we joined forces with this GeoAir community and the OGC community and started on GeoParquet. We just went to 1.0 a few months ago. It's quickly getting adopted by this wide ecosystem. I think there's already 20 tools and libraries, plus lots of data available in the format. It's emerging as this format for the web. So this demo is 3.2 million points kind of rendered through the browser, and first-class support in DecGLs in progress. I think it's also proven uniquely useful for large-scale distribution of geospatial data. So this is Google's open building data set. It's about 150 gigabytes. But it's distributed this way. You can download a Parquet file for a particular country, but you can also treat the whole set of data as a single data set and query and stream just what you want. This is a little cool tool called DuckDB and kind of lets you work with this entire set with no server in the mix. It's just using the same sort of HTTP range request to make its queries very efficient. You can even run it in the browser and WebAssembly. You know, we're still very early in this ecosystem, but I think it's got a ton of potential as a way to distribute large data sets. We're seeing more of these really large data sets with computer vision. One of the leading ones is Overture Maps. Their latest buildings data set has 2.2 billion buildings, and it's all distributed by default as GeoParquet, as there are all of their layers. So yeah, really exciting to see these big data sets adopt it. So I wanted to end a bit with some of the implications of these formats. I've been starting to talk about the idea of a cloud-native spatial data infrastructure. I gave a full talk on this at FOSS4G North America. So if you're interested in learning more, check that out on YouTube. It's pretty easy to find, and it's one of the favorite talks that I've given. There's a lot in the talk, but the core concept is to update this idea of a spatial data infrastructure. Early in my career, I was really compelled by this vision. You know, like, let's make lots of open geospatial information that can lead to lots of cool uses. But I think it got bogged down in an architecture that was just a bit too complicated for the majority of data producers. And it clearly hasn't been successful. There isn't tons of really great open geospatial information in standard formats. If there was, I'm pretty sure we'd see LLMs able to easily answer questions about the Earth. And instead, it kind of usually draws blanks. So the core idea of a cloud-native SDI is to radically simplify what's needed to participate, to make it easy for people to upload data to the cloud in one of these formats. And I believe it's better in a few fundamental ways, kind of scale, ease, and cost. So yeah, the scalability is provided the object stores, which is the most scalable part of cloud infrastructures. Instead of trying to stand up this custom cluster of servers, it's far easier to publish. You can just drag and drop into a cloud console and be working with it right away. This is COPC, another great format. And I think we can make it even easier to share and publish. And it's far cheaper. A cloud bill for storing a terabyte of data and accessing it is $30 a month. I think all vector data of most states would fit in a terabyte. Image is a bit bulkier, so tens of terabytes, a few $100s, but you're going to have to pay storage costs anyway if you're running a server. But it just says just do this. So I believe prioritizing the ease and cost of publishing data can fundamentally change the dynamics of the SDIs so they become useful, and lowering the barriers to participate will enable a set of data publishers who haven't had the resources or capabilities to actually stand up a server. So we're still early in this journey, but I believe many of you on the webinar are in a good place to help. The core formats are in a very solid state, and I encourage you to adopt them for internal workflows. Things are going to work better, but even more impactful is to start to publish any public geospatial data as cloud-native formats. I'm sure this is actually a lot simpler than you imagine it would be, and tools like SafeFME will make it super easy. But this simple act of making data available in these formats on the public cloud can really help build the momentum. So yeah, if you're interested in learning more about how you can contribute to the cloud native spatial data infrastructure idea, don't hesitate to reach out to me. And yeah, with the latest Safe FME advances, you should really have quite an easy time publishing the data as you're learning the rest of the webinar. So yeah, thanks to the Safe team for inviting me to speak, and to you all for taking the time out of your day to join. And thanks for the extra 3 minutes. I think I went a bit over on my time.
Fantastic. Thank you so much, Chris, for your time this morning sharing. If you do have any questions for Chris, I know he has to dip offline in a few moments, but definitely get those into the question panel. And even if they come in after, I'm sure we can pass those along to Chris.
So I'll just, while anybody comes up with a question or two, Chris, what do you think is next? When you look ahead at the work you've been doing, what's the next part of the trajectory?
Yeah, I've started to have draft blog posts on this. To me, the next thing really is schema level interoperability. Like we've done the formats, for all the different types, but like interoperability, if you send me a data set of buildings and I get it from San Francisco and I download one from Arizona, they're all different fields within them. So how do we make it so those are the same fields and you can just start working? And we sort of did that with STAC, and I think there's some cool ideas there, but how do we do that in GeoParquet with sort of any set of vector data?
That is so interesting, because in many ways that's where Safe software started its job 30 years ago. I wonder if LLMs will be able to help with that problem.
Yeah, I think so. So actually, yeah, this blog post I have coming, I used an LLM, like I did a custom GPT to like query a San Francisco data set. I wanted to ask like how many buildings are over 200 feet tall in San Francisco. And it sort of guessed like based on this data set, but that's where I think if we can agree to harmonize like, and what these fields should mean, then I think we can have, I think LLMs can help with some of the fuzziness, but I think LLMs really help make it so it's accessible to anybody. You don't have to load a GIS. You can just start to ask questions of these data sets if we can get kind of global scale data sets and even just everyone publishing in the same schema.
Yeah, and I think also there's the aspect of making our data visible to LLMs. And so that could be whether it's metadata in STAC or exposing the schema from GeoParquet to make it searchable by LLMs.
So it looks like we got a question there from Adriano about if GeoParquet is supported by things like AWS Glue data catalog. Do you know about that, Chris?
I don't know Glue data catalog per se. It is likely not that GeoParquet itself is supported out of the box yet. We're currently talking to most all the cloud data providers, and it's somewhere on their roadmap. But the nice thing about GeoParquet is it is Parquet. So like the only thing you don't get from GeoParquet is like kind of instantly understanding the projection, but it's really easy to like, I'm sure Glue supports Parquet. And so any GeoParquet data you could easily get into Glue. You might just have to do like one little transform to like, spatialize it yourself versus having it automatically know that it's spatial.
Okay, well, you know what? We should let Chris get on to the next part of his morning. He might join us at the very end. Chris, if you get back, maybe we'll see you at the end. But thanks so much for sharing with us right now. And we'll hand it off to Elizabeth to take us to the next part of our presentation.
Fantastic. Yeah, I think we'll actually pass the baton to Michelle now, who will screen share our next section here.
Okay, great. Here, let me get this started. So hello, everyone. Michelle Roby here. And today I'm going to be giving you all an introduction to Cloud-Optimized Formats. And before I get into that, I just wanted to share a little bit about the organization I'm coming from. Radiant Earth is the general organization that I am a part of, and our mission is to be an incubator for data-driven initiatives, services, and 21st century institutions needed to foster shared understanding of our world. So what that looks like in practice is having these smaller initiatives to do the work of data sharing and data access. So the two main initiatives that we have going on right now is the Cloud Native Geospatial Foundation, which is a part of why I'm here with you today. Our mission with Cloud Native Geospatial Foundation is to increase adoption of highly efficient approaches to working with geospatial data on the web. And then on the other side of another initiative I'll just mention, but not a part of really what I'm talking about today, is something called Source Cooperative, which is a data publishing utility for easy sharing of data over the web. And so they work together, but today I'm representing the Cloud Native Geospatial Foundation with the education piece of Cloud Native Geospatial Formats. And so what does cloud optimized mean? Chris gave a great overview, and you may come in with some history on your own, but just so that we're all on the same page when I'm discussing these formats today, the big part of cloud optimized is that the idea that data is going to be read more than it's written. So how do we make data easy to read as a user? What this looks like in practice is many components, the first being partial reads. So an analogy I like to use is if you're watching this recording of a webinar on YouTube, you don't really want to download an hour-long video before you watch it. You just want to start watching it bit by bit. And so the concept of streaming is representation of partial reads. So you can watch minute by minute throughout the video, or if you want to skip around, you can do that as well. Parallel reads is also part of this. So just being able to have the power to do things in parallel of reading in the data. And so that just increases the speed of reading that data. And having file metadata on the data. So usually this can be either a part of the data or outside of the data, like an external file describing the data. And this kind of loops back into that YouTube example for watching this video recorded. If you want to look at minute 37 of a video, you don't have to download everything around it to get to that minute. And then it also knows how to jump you to minute 37 and what that data is. So the metadata is saying, hey, at minute 37, Michelle is talking about cloud optimized formats. So you can just skip to that. So those three components are the real base of cloud optimized data. Cloud implementation can also include the accessible, like data being accessible over the internet and typically HTTP range requests. Cloud optimized often also supports lazy access. So that concept that we're talking about, not having to download an entire file, but only reading what you want. So if you only need a subset of the data, that you can download it just like that, and not having to load everything in. Intelligent subsetting, so for a geospatial example would be if there's data for the whole world, but you're really just looking for a city or a town, you can just subset that data and download just what you need. And then a really cool aspect of cloud optimized data is that it integrates well with existing libraries and distributed format frameworks. And so there's a whole ecosystem of work around this that allows for ease of use of that data. So why would you want to cloud optimize your data? So I'm going to keep hitting the same point over and over, but it's an important one. Just that concept of less downloads. So we can see the benefits from the provider side and the user sides with cloud optimizing data. For providers, less downloads is beneficial because it means reduced costs and then reduced server load. And then we can also, as providers, serve more people with the same resources. And so less downloads is beneficial to the providers and then also for users. So downloading less data means less time waiting for the data to download, less time throwing away irrelevant data or masking in a pre-process or like a post-processing work, less data downloaded into memory. So especially if you're working with a larger data set that you can't download all the data onto your computer, And then that leads into bringing the compute to the data. So being able, cloud computing, the concept of being able to do the analysis in the space where the data is. So if that is the cloud, and so you don't have to have space on your own personal computer to perform the analysis. And this also, in addition to the whys, there's many other great opportunities with cloud optimized data, including serverless data. So not even just reducing the server load for a provider, but actually having like the opportunity to get rid of servers completely and do all the work in the cloud. And then additionally, dynamic tiling, cloud computing that I mentioned earlier, and many cool stuff that is on the way. So Chris gave a really great intro and showed some of this, so I'll be quick with it, but the concept of what is cloud optimized data. So there's three components that we can kind of visualize. So Chris gave the example of the COG, the Cloud-Optimized GeoTIFF, and how it's read-oriented file structure. And so the computer or API can read of like, knows exactly where to go to find the data that you're looking for because it has this metadata and then organized files. And then with the COG, this is an example of pre-rendered overviews or indexes. So you can preview the data if you're not using one of those great tools that Chris showed, which I'd recommend with COGs, but if you are working on your personal computer or viewing it beforehand and you don't want to like load the whole data set just to view it, you can, in COGs there are built-in overviews. And so you can see it, and as you zoom in, the overviews change and become clearer. And so you're not taking all of that detailed data all at once. And then my favorite concept and like the theme of the day is the reading what you need. So if I'm only looking for data within this red box, I'd only have to download these 4 blue tiles, which would be chunked up in like a smaller compressed file, whereas otherwise with a more traditional format, you'd have to download multiple scenes of data, and all the data outside of it would be data that you wouldn't need. So this is that idea of like what that data actually looks like in practice. So it's important to talk about too the side of what makes cloud optimized challenging. If it's so great, why isn't everyone doing it yet? And in addition to just historical things that have already been set up and pipelines, there are many existing geospatial data formats, not just rasters. The example I just gave was the benefits of some the Cloud-Optimized GeoTIFF, but in addition to raster, there's points, lines, polygons, so vector data. There's also point cloud data from LiDAR. So all of these data types are different in the way that they show up and how you'd work with it. And so therefore the way that it needs to be stored have different needs for optimization. And then it's also very user dependent. Users must learn new tools with the data, and that might differ depending on the user and their needs. So this table is basically an explanation for different data types or like imagery types or data types needing different data formats. So these rows are, if you are able to see it, are lists of data types. So imagery, swath, trajectory, point cloud, in situ data. And then on the columns, there are lists of the types of data formats that work best with that data. And so as you can see, we range from high in the green of, hey, this is a great fit for this data, all the way to poor in the red of, this does not work well for this data at all, not recommended, and everywhere in between. And so depending on what type of data you're working with, the format that you'd want to use differs. So there's not one size fits all with that data. I'll pause right now for a poll. I don't know, Elizabeth, if you want to speak here.
Yeah, fantastic. Thank you. So I've just published this poll in the polls tab on the bottom right. We'd love to know which cloud native formats are you currently using? And if you aren't using any at this point, there's also an option for that. So we'll give everyone a moment there. It looks like most folks say none so far, so definitely a lot of opportunity to come then in that case.
Yeah, it's like Wayne Gretzky said, you got to go where the puck is going to, not where it is now. And so glad that you're all part of this webinar so we can all learn about these and figure out where we can apply this amazing technology.
Excellent. All right, I'll hand it back over to Michelle.
Great. Okay. So just as an overview, as I mentioned, different data types need different data formats. And so since this is an overview session, I picked out 4 main data types that you all might be providing or using, and their recommended data format, Cloud Native Geospatial. And so for raster data, currently what we view as the best option is the Cloud-Optimized GeoTIFF. Chris gave that great history on it earlier. And if you have multi-dimensional raster, which I'll talk about a bit more in a bit, something like ZARR or Kerchunk is a better fit. Point clouds, so LiDAR data, something like COPC, which is Chris also showed a little bit of, so Cloud-Optimized Point Cloud. There's also something called Entwined Point Tiles is a better fit for cloud point clouds. And then for vector data, so traditional like shapefiles and whatnot, FlatGeoBuf and GeoParquet are what we recommend currently. And each of these data formats actually has been around for some time, at least like somewhere in the last decade, if not earlier. But they have a replacement for a more traditional format. So the Cloud-Optimized GeoTIFF replaces the GeoTIFF. ZARR and Kerchunk are replacing NetCDF or HDF5. Point clouds are replacing, or Cloud-Optimized point clouds are replacing LAS files. And then GeoParquet and FlatGeoBuf are replacing shapefiles, GeoPackage, and GeoJSON. And they all have some form of standard either in the process or an already established open geospatial like OGC standard. And so there is a lot of support around all of these cloud optimized formats. And so the raster, the cloud optimized GeoTIFF, I'm going to just go talk about each of these really briefly, but at the end, I link a resource for you. It's a Cloud Native Geospatial guide for you to learn a few more details of all of this. But just as an overview, cloud optimized GeoTIFFs are great for raster data, so like multi-banded raster data. Chris gave the example of Landsat that is hosted on AWS and it's stored in COGs. The great part of this is that it's tiled. So instead of this photo is a Landsat scene, you don't have to download the whole scene if you only need, let's say, this yellow square in the corner. So you can download just that square instead of the whole scene. And then there's also those tiled overviews that I mentioned earlier. This is just the data setup. So it's got the metadata, the overviews, and then that raw data. And you can get this data over the web through HTTP GET range requests. If you have multi-dimensional rasters, you can use something like ZARR. So multi-dimensional rasters would be something like if you have a data set that has many data variables like climate or ocean data. So this example here, we've got the data variables and then the coordinates that describe the data. So temperature, pressure, and then the description of the data of the elevation, land cover, and location. So when there's data like that, something that can handle multi-dimensions is a better fit. ZARR allows for chunk storing of this complicated data. So chunks are 3D cubes of data variables, and then each chunk of that data is compressed. And then through the metadata, you can find exactly what you're looking for and then just decompress the data that you want. ZARR has got a lot of movement behind it, and it's very, very cool. And if you cannot, don't have the luxury of creating your own data set or making data from scratch or converting data that already exists into a new format, you can use something like Kerchunk, which is a way to create that ZARR metadata piece, so that external information about where everything is located for archival formats like NetCDF and HDF5. And so Kerchunk basically negates the need to create and store copies of data in completely different formats, but allows you to read the data as if it was ZARR and use all of the tools around ZARR for these other formats. For vector, so those were both raster examples. For vector, GeoParquet is that lead format right now. It's utilizing Parquet standards, and so I won't dive too much into it because Chris described it some, but it's highly compressed and really great for vector data. The one downside right now is there's no spatial indexing. That is in the works, but there's things to be said about it. Chris has a better perspective on that, but that is the one big downside to GeoParquet at the moment, but it's highly compressed, which is its big perk. And then FlatGeoBuf. And so that one is an example for vector data that is spatial indexed. And so if you need that right now, and you don't have time to wait for GeoParquet to develop that, FlatGeoBuf is an option for that. Chris mentioned this a little bit for cloud-optimized point clouds. If you have LiDAR data and you want to store it in the cloud, cloud-optimized point clouds or COPC is our recommended way to go. And since I'm running out of time, I'll leave you with the guide that we have hosted on cloudnativegeo.org. This was created in conjunction with Development Seed and Impact at NASA. And it is a great just run through of all of the basics that I've described, but with more detail on each data format, with more details and links and more education around it. So if a certain format says, okay, this makes sense for my data, I want to learn more about it, this is a great jumping off spot for you. And just to finish off, I just wanted to mention, as Cloud Native Geospatial Foundation, some of the activities that we're doing, and the reason that we're around is things like this, webinars with education. We do a lot of holding the space. So having meetings and collaborations with the thought leaders in these different formats, and having sprints. And so the development sprints, we held the STAC sprint. Chris mentioned some about SpatioTemporal Asset Catalog. We held that sprint last September. Next week, or in 2 weeks, we have the GeoParquet Community Day in San Francisco, education and hacking. And then ZARR sprint in New York City in February, where we'll be developing the more GeoZARR and the HTTP extension for ZARR. We have paid fellowships that allow us to support engineers that are doing great work in the field. And then we're sponsoring the future development of these cloud native formats. And then, just as I mentioned earlier, provide documentation, tutorials, and educating content, including this webinar that I'm giving to you all right now. And so this is where you can find us. But with that, that is the end of my talk. And yeah, I look forward to some questions.
Okay, I think what we'll do is, thanks a lot, Michelle. That was awesome. That was a great overview. I'm going to go ahead and wrap up. some of our slides here. Just grab my. So you guys are able to hear me and see the deck okay? So we've got about 8 minutes left. I'll just zip through a quick overview of our cloud native strategy and some of the formats we currently support. And then I think we'll, I think it was great to hear all this detail from both Michelle and Chris, and I do appreciate them being it's really packed in our agenda today. And so we will save some of our demos for a part 2 webinar, which we were already discussing anyway. So let me just jump in here and just do a quick wrap up on with talking a bit more about FME and what our cloud native strategy is. Ultimately, as you know, Safe Software and FME is all about, our whole reason for existence is to give you better access to your data, whether that's easier ability to publish your data or easier to consume data. So basically removing barriers. And in the area of cloud native, that's all about doing that over the web, where most of the data has moved already. And so we're lowering the bar for publishing your data. We're targeting the key emerging cloud native formats, as Michelle mentioned, across all the range of data types. We're also realize that not everything is going to live in the cloud, and so we need to support hybrid environments. And some of your processing might be on-prem or local, and some of it might be in the cloud. And basically making sure we leverage the built-in optimizations of these formats. So we're not just, all the lazy evaluation and filtering and stuff is properly supported. And so, here's the format support that we currently have. So as we've heard discussed, Cloud-Optimized GeoTIFF is really the pioneer. And then STAC is very essential. It took us a little bit of to get STAC right. We've been working on that for a while. And so we're feeling very good about that. That's actually delivered as a package from the hub. So it's a way we can sort of do continuous release on that. And then you can see FlatGeoBuf, GeoParquet for vector data, point clouds, COPC, and ZARR for time series. So just keep track of the time here. I'll just mention a few words about STAC. So we've got both the metadata reader and the asset reader. And basically the metadata reader allows you to read about the data, so you don't actually have to retrieve all the data. You could use those readers in series. So first check the metadata, figure out what you actually need, and then go grab the assets. And so we've got these demos which we'll make available, and we'll also get into more in depth in our next webinar. Basically, this just demonstrates how to get at how to read this from the STAC API. We've got some spot imagery on S3, and Kalen built a great demo which shows how you can read the catalog, figure out which data that you need, and essentially just read what you need. And so what happens is the STAC actually has links that I won't go through this whole thing, but I guess it's because it's got audio. Skip to the next. Yeah, so the quick summary on this is that, with FME's S3 connector, we can publish COGs to the cloud and then make it easy for STAC to reference that and then allow you to consume it. And a nice little animated GeoTIFF here showing the resulting data. I think I'm going to have to skip through most of this. I mean, here you can see, again, you've got a much larger data set on the left and then just reading what we need on the right. So let's say for the project area. And what was neat about this is Kalen generated an HTML report with embedded images and links. And so again, I won't go through the demo. I just have to figure out how to skip.
Come to part 2 and see the demo in slow motion.
Mm-hmm.
Yeah. Yeah. So using both FlatGeoBuf and COG in this case, and then generating this HTML report where we've got a little snippet, and you could, click on the links to get the full data set. Let's see. Yeah, and here we're basically, Kayla made an upload service, which allows you to drag and drop data sets onto FME Flow, and then they get uploaded into FlatGeoBuf, and you can see the list of data sets that have been added there. So again, making it easier to publish your data. Here's just some snapshots of some cloud-optimized point cloud. And again, here what we're doing is in the spirit of just read what you need. Normally, you'd have to download, as Michelle was mentioning, both Chris and Michelle talked about earlier, you've got this typical use case where you'd have to download many different tiles, mosaic them all together, and then clip out your project area. Now, all you have to do is query the X, Y, Z, min, max range, and just get the data you need associated with your project. So it just speeds things up massively. And the same thing goes for ZARR. In this case, we're looking at the XY time extents. And so I've got a bunch of climate data from the climate pilots and disaster pilots that we're working on in southern Manitoba. And so there's a data cube covering half the province across 1,000 time steps, monthly time steps. So we can just extract, let's say, 10 years of data just around Winnipeg and do some temperature precipitation analysis just on that. And even though the data structures are somewhat different, we can go straight from NetCDF to ZARR with, I love the Zero Transformer workspace, and you get a usable result in the ZARR. So I've got some demos around that. There's a link to the pilot if you're interested in finding out more what we're doing in the climate and disaster space. So obviously, in the disaster space, you want to be able to share data rapidly without having to worry about configuring servers. And in the climate space, those two are actually closely tied. We need to understand the impacts on climate in order to adapt. So the Parquet one, I found this was an interesting table where I ran a whole bunch of tests on different types of access. And there's a little bit of debate around Parquet. How cloud native is it? And I guess it all depends in terms of how you publish the data. So you can see when we partition the data, it actually does perform quite well. And I've tested locally consuming it, S3 to local, and cloud to cloud. And you can see that the partitioned GeoParquet is the fastest when compared to trying to, say, read a GeoPackage or OpenStreetMap. So I think I'm just going to jump to our integration strategies and conclusions, and then we'll wrap it up for today. I like what Chris mentioned when we were chatting yesterday, when I was asking, what are your key takeaway messages? And he's like, start publishing now. Like, the barriers to publishing are just not what they used to be, and we need to get data. We need to get the data out there, exposed, making use of it. You could also say start consuming now, because there's tons of STAC and COG available, as you'll see in the resources slides from folks like NOAA and USGS and Copernicus, ESA. So there's lots of data out there that you can make use of. A lot of it's free to access. Minimize your traffic footprint, keep your processing close to the data, and think carefully about your optimization strategy, because that will be based somewhat on your use case, and do test. I found that whole testing quite informative when I was doing that with the GeoParquet. And do realize that you do have some heavier pre-processing, because we are optimizing for read structure, as Michelle mentioned. And so sometimes we have a larger server-side footprint in order to make it easier to read. A bit of pre-processing involved with that, and updates can be a challenge, but I think if you have an automated system, that makes updates easier. So I think that's pretty much all the time I have. Obviously formats like COPC and ZARR are a bit newer, so there's not as much available out there. So just to sum up, Cloud Native is all about making it easier to publish your data without having a server, or at least without having to configure a server. You just use the cloud infrastructure that's already there, and it automates, auto scales, and it makes it way easier to get your data out there and for people to consume it. And from the consuming side, just read what you need, and that's kind of built into Cloud Native. SAFE strategy is to support the emerging standards. There's certainly an emphasis on open standards there, and making sure that we give you the tools to make it really easy to integrate Cloud Native with all your other data flows and also work across hybrid environments. Keep your processing close to the data, minimize your footprint with reader-side filtering, and participate with these open standards communities, if you want to sort of stay ahead of the curve. And the bottom line there, and I think Michelle also mentioned this, both Chris and Michelle have mentioned, there's no one size that fits all. So you really need to know your requirements and do some testing. So there's our resources, and I guess we can go for any questions, perhaps. Anybody else wanted to pop in with key takeaways in terms of conclusions? I don't know, Dale or Michelle.
I'm going to have a question for Michelle that's asked by Paul, and I'm going to expand it a little bit. We talked today a lot about rasters and vectors, but what about 3D data? And is there a concept of cloud native for 3D, or what's your gut on that, Michelle?
It's not my area of expertise. I'm really not sure, because it's the only version of that. I guess ZARR, because you can have it's like multi-dimensional raster, but I wonder to what extent that could do 3D too, because it can take in so many arrays, so not just X and Y, but Z and everything else. So would be my guess on that. And then if it's just point data, something like the COPC, the Cloud-Optimized Clouds, because that also takes into account Z. But yeah,
if I can jump in,
I
was just going to jump in quick on that. Dale, when I was looking at FlatGeoBuf with GeoParquet, apparently FlatGeoBuf, I think they both, Chris could speak to GeoParquet a bit more, but I think they both have some basics 3D support, because they both support Z values. But I think for solids and surfaces, FlatGeoBuf has some support for that.
Chris, do you know if there's any work happening on, I guess we have things like I3S from Esri and of course the cesium stuff that are optimized ways of storing 3D, like solids and buildings and things that way. But are those sufficient, do you think, for the 3D world, or is there any interest in this same sort of innovation happening there?
Yeah, can you hear me? Just be sure.
Yep.
I think I haven't looked deep into those. My suspicion is they're pretty close to cloud native. They're not big server formats, so it's just how you would kind of organize them and set them up. It's a good question. I think cloud native stuff is a bit better all in one file. I think we didn't talk about it too much, but PM tiles is I think the best cloud native tile format. So that's what I'd maybe see in 3D, is some sort of thing like that, where you're actually using range requests. I think you could probably stick 3D tiles on a server and treat them statically today, just like you could with tiles before. But I think that's a little less cloud native than a PM tile. So I could see some sort of packaging to make it just a little more compatible. But yeah, I think there's space for it. I sort of see everything should evolve to be a bit more cloud native and a bit more static. And I think we're seeing even innovation at the edges where how do you make it so you truly don't need a server? And I don't think we're there yet for 3D, but I'd see the potential for it eventually. I don't see it as super far away, but I could see some incremental steps that get it even more kind of native-y.
So I was just wondering how cloud friendly do you consider, let's say, I3S and Cesium? I mean, they are optimized for web.
Yeah, I haven't looked super deep into the I3S. I think the thing is, yeah, it's just like you can put them on the cloud, you can access them on the cloud. I'm like 90% sure, but I think you're not using the HTTP range request. Like you're just kind of, they're just like a bunch of individual files on the cloud.
Yeah.
And I don't think that's like, I mean, that's sort of one of the fundamentals. I don't think it's huge, but it's like what you get on the cloud with like, you know, 1 million or 1 billion like files. It's like a huge pain to update all of them. And it's like costly to like do all the requests for that. So it's like I consider it like cloud accessible, but not like cloud native. Like to me, cloud native is like built from the ground up for the cloud, you know, and like what are the choices you'd make about the format to enable that. And so I think those are like pretty close. Like FlatGeoBuf is interesting. I do consider FlatGeoBuf very cloud native, but like Bjorn that wasn't one of his design goals, you know, like he just like the way he did it made it work that well. And like, you know, GeoTIFF was not cloud native. We were able to like reorganize it a bit and get it cloud native. So like, it's more kind of the design decisions, but like some of them may be very close. So I think like my hunch is that the 3D ones are pretty close, but like that if you really were to start from scratch and be like, hey, well, I want to make a 3D thing that like lives natively in the cloud and clients stream from it, my hunch is you'd tweak some things or design it like a little bit different. And yeah, maybe it's just all in one file versus a bunch of little files, but yeah.
So just jumping in, there is a cloud-optimized zip file floating around, right? Which meets your definition, Chris, because it has the metadata there that you can do range requests and just pull out the parts of the zip that you want, which is following that. The questioner Paul asked about the USD 3D format. I don't know enough about how that format is structured, but perhaps there would be a way also to retrofit some kind of an index on the front that would let you grab pieces. But I really want to get to, because we talked about this in our rehearsal, and the question is, and we'll start with Chris and maybe Michelle can weigh in. What do you mean without a server? Data need to be stored somewhere. So, and Chris, your history kind of informs this answer, I think.
Yeah, like, so yeah, without a server is a bit, yeah, you're right. There is a server somewhere. Like, I mean, the funny thing to me is like, there's serverless, like on Amazon, you know, which, and as a trend, which is actually more of a server than these things. So serverless is like, I'm not running a server. It's just a process that I connect to, but there's clearly a server running in the background. With these, the server is really the S3 or object store API. And so like it is not a server, you know, like you can do HTTP requests for it. And as an API, you can even upload, delete, you know, change stuff. So really under the hood, the server that replaces things is S3, but like we are only using standard HTTP verbs. We're not inventing new like get capabilities operations. Like there's not like these other things that return stuff. All it is says get, you know, it's get, post, you know, like the 4 HTTP verbs, like that's your server. So I can see that there is a server in the mix, but I think it's like a radical simplification where like you are not having to run a server. You're not even having to engage a serverless thing, which scales infinitely, but you know, can also have cost scale infinitely. Like your only cost is S3, and yeah, you're charged for get requests there, but it's the cheapest server that there possibly is that I know of. So.
Yeah, so basically it's just you've got a web server. You're hosting something on a web server, but you don't have a whole stack of other servers that typically came with setting up, let's say, a traditional geoportal. Exactly. So that's when we're talking about serverless from a geo, you know, cloud native perspective. It's not having that whole stack to configure. You just need some web hosting.
Yep.
Anything you'd add to that, Michelle?
No, that was, I think, a great answer. I'll leave it at that.
Yeah, and it's a big enough movement that there's really like a whole foundation around that it's a really important initiative that's underway with. Brad asks, is there a cloud-based database system that could take the place of SQL Server? And there's a bunch of different answers there, Brad. But of course, you can run SQL Server in Azure, and then you right away just have that. but there's some of these, depends what, as Dean would say, what your needs are. If you need to be updating things, then you should be looking at or considering a database. Otherwise, in many cases, if it's primarily data that isn't changing very often, these techniques we showed today are a great way of avoiding some of the complexity that comes with having a database for if all you really want to do is just read and publish data.
Yeah, I think in the coming years it's gonna evolve. Like one of the big trends in the mainstream data world is these table formats. So like Iceberg and Delta Lake and whatnot. And it's this crazy trend. I mean, it's super cool where database is essentially disaggregating storage and compute. Like the query and the storage are different. And so like BigQuery and Snowflake are embracing this, and like they'll support Iceberg, where you could store all your data in Iceberg. And Iceberg under the hood is Parquet. Like, I mean, it can be other things, but it's just kind of it's a layer of metadata that lets you do transactions on top of Parquet data and treat it as a table. And like, yeah, it's this mainstream data trend. And yeah, I get into this in my talk some, but like, you know, I think that's where we're going to see like the true amazing SDI is going to be like the cloud is the database. You know, that if you store it in Parquet, there's going to be enough tool set where you can really kind of treat that as database. And that's still early, but like it is a trend you see in the mainstream data world is people just sort of like using Parquet as your database. DuckDB, you can just like query a Parquet file as if it's your table. You don't have to import into DuckDB. You can just do your SQL commands on it. So it's early. I'm definitely, yeah, right now, use a database for those things, you know, use a cloud one, but keep an eye on these kind of exciting trends where I think there's going to be even more just like disaggregation between those, and you get to pick your query engine.
Yeah. It's a fascinating world that's changing rapidly, and definitely worth keeping an eye on. But as Chris said, Parquet and then GeoParquet are going to be foundational moving forward. So your time spent understanding those formats and maybe using them is well spent. And boy, do they ever work fast anyway. Like I know if your data is just local, somebody asked about would GeoParquet replace shapefile, and I said when Parquet replaces CSV. But I know that for any demonstrations and any work I've been doing in the last while, since FME supported Parquet, I absolutely want to use Parquet instead of CSV every day of the week. And so I think that's that switch may start happening very, very fast.
I just want to throw out there for the audience that because it looks like we definitely need a part 2 here. We had just too much to get through in one day. I would welcome any feedback you have in terms of what you want to hear more about. Maybe it's specific use cases. Maybe it's the COPC ZARR stuff. Yeah, so do provide your feedback and let us know what you want to hear about. I'm assuming if you are interested in a part 2, let us know.
And that way Kaylin can show her cool demos. Sorry, Kaylin, you didn't get any airtime today.
Hey, that's okay.
I know that Kaylin has great stuff. Elizabeth, you're going to promise we'll do a part 2?
Absolutely, yeah. It'll be coming this spring. So we'll make sure that everyone on today's call gets an invite email sent out for that. So yeah, definitely keep an eye out.
I just want to express my deep thanks to Chris and Michelle. Thank you so much for sharing your expertise and for all the work you and your organizations have been doing to drive these things. These things don't just fall out of the sky ready to use. You are doing work that's going to change the way people use spatial data and the volumes of it in the years to come and the weeks to come and the months to come. And it's just an honor that you shared your time with us and our audience today. And Dean, Kaylin, Elizabeth, it's always fantastic working with you. And Elizabeth, I'll hand it back to you to wrap us up.
Fantastic. Thank you, Dale. And thanks everyone else and our audience, of course, for joining us today and spending the time with us. If you do have a brief moment to fill out our webinar survey, I'll drop that link in the chat here. We appreciate any feedback so that we can continue to improve our program. And once again, just thank you so much to our guest speakers today and our safe speakers and our whole audience. Hope you all have a great rest of your day ahead. Bye for now.
Thanks, Chris and Michelle. Appreciate it.
Yeah, happy to be here.